Alright, so let's talk about significant figures. Significant figures are every known number plus one number that you're not certain about. It's an unknown number. It's an estimated number. That estimated number is called the uncertain digit. It's the first sig fig going towards the left. Now, let me show you some examples to actually help you understand what this really means. You'll see this later on when you get to the assignment. So here we have some different measuring sticks. Specifically, they're meter sticks. So the first one goes from 0 to 1 meter, and that's the only amount of measurement it has. It starts at 0 and it ends at 1. And you're trying to measure this door. So this is a door, in case you can't see. There you go, it's a door. Well, how big or how wide is this door? Well, you pretty much have to completely estimate the entire way. So clearly it's more than halfway past the through the meter stick, and it starts about right here. So how far is this? The book estimates it's about 0.8 meters. I would guess maybe it's about 0.7 meters. Okay, you don't really know. This literally has one sig fig. You have no idea. This is the uncertain digit. You have no idea. So this door, using this meter stick, you have to make a complete guess. You know it's bigger than 0, but less than 1. So they said 0.8, you may even see 0.7. If we look at the next meter stick, it goes by 10 centimeters, 20 centimeters, all the way up to 1 meter, which is 100 centimeters. So clearly you notice that the door is between 70 centimeters and 80 centimeters. So you know for a fact it's at least 0.7. Now they changed it to meters. So you're like, wait a minute, why is it 0.77? I thought it was 77. They changed centimeters to meters. So clearly you know it's at least 70 something. Well, since it looks like it's past halfway, you know it's bigger than probably 0.75. But again, you don't know. This last 7 right here is a complete estimate. It's the uncertain digit. You know it's going to be between 0.70 to 0.79, so they said about 0.77. I could say this was probably maybe 0.78 or maybe even 0.79. Again, so with this, you say you know for a fact it's 0.7, but then the next number you don't know. So that's sig figs. So I have 2 sig figs and 1 uncertain digit. Okay, that first sig fig, this one right here, going towards the left, is your uncertain digit. It's the one you don't know. You know for a fact it's 0.7, but you don't know that one. Let's look at the last one. In the last meter stick, they go, every little number here is 1 centimeter. So if you count over, clearly you're in the 70s. So 71, 72, 73, 74, 75, 76, I think I'm miscounting. 1, 2, 3, 4, 5, 6, 7, there we go. So you know for a fact it's 0.77, and then it's between this 77 and 78, so somewhere in between 77 and 78. So since it looks like it's just barely past that little mark right here, the 77, they said 0.772. But again, you know for a fact it's 0.77 centimeters, but you don't know this number right here, so that's the estimate. So again, with sig figs, it's all the known numbers you have plus 1 uncertain digit. And so it's very important when you do any measurings in any science class, you mark down all the numbers you know for a fact plus 1 number you're not so sure about. Plus 1 number you're not so sure about. And the rule is you always go 1 less than what the meter stick tells you. So for example, on this one, you know for a fact it's going to be at least 1, you see at least 1 sig fig, so you're going to have 2 sig figs, the second one being the uncertain. This one, you know for a fact it's 77, which is 2 sig figs, but then you guess on the third one. So there's always 1 extra number there. So that's sig figs. That's why we have them. It helps us figure out measurements. And the more significant figures you have, the more, I'm not sure if the word's precise or accurate. I think the word would be accurate. There we go. The word would be accurate. You'll learn about precision accuracy here later. It'll be more accurate. So, whoops, not what I want. Let's go over rules for determining how many sig figs there are. Now, in one of the videos you're going to watch, Mr. P has 4 rules. I used to have 4 rules. I actually knocked it down to 3. In the textbook part you're going to read on the PDF, they have 6. You really don't need to know all 6. These basic 3 will get you through any problem. So what are the 3 rules? How do I know what's a sig fig and what's not a significant figure? Well, number 1 is anything that's a non-zero number. Anything that's a non-zero is significant. So for example, in the number 7, I have 1 sig fig. In 15, there are 2 non-zero numbers. 1,443 have 4 non-zero numbers, so there's 4 sig figs. In 130, there are 2 non-zero digits. Therefore, there are only 2 sig figs. Now, you can change this so that 130 has 3 significant figures, but you'll see how to do that in Mr. P's video when you talk about scientific notation. Well, how can I make 0 significant? Well, Rule 2 helps out. Rule 2 says any 0 between sig figs are significant. So in 506, this 0 that's in the middle is in between non-zeros. So there are 3 sig figs. 40,605. This 0 is in between a 4 and a 6, or it's in between a 4 and a 5. Doesn't really matter. This 0 is in between a 6 and the 5, or it's in between the 4 and the 5. Either way, it's in between sig figs. Therefore, these zeros are all significant figures. There are 5. 1,009. Both these zeros are between the 1 and the 9, which are non-zeros, and therefore they count. There are 4 significant figures. So again, all zeros in between significant figures count. Rule 3, which is the most complex one, says all zeros to the right of the decimal and to the right of a significant figure are significant. So in 7.20 times 10 to the 5th, so this is scientific notation, there are 3 sig figs. How? You don't worry about this times 10 to the 5th. This is more for like placeholders where the zeros go. So you don't worry about this 10 to the 5th. It's right here that matters. There are 2 non-zero digits, and then this 0 is to the right of the decimal, and it's to the right of a significant figure. The 2 or the 7, it matters not. So since this 0 meets both requirements for Rule 3, it counts. So that has 3 significant figures. 456.0. Again, I have 3 non-zeros. That's Rule 1. And then this 0, yes, it's to the right of a sig fig, the 6, the 5, or the 4. And it's to the right of the decimal. So therefore, it has 4 significant figures. 0.007602 has 4 significant figures. Why? You have 3 non-zeros, the 7, the 6, and the 2, so there's 3 sig figs. This 0 right here actually meets 2 rules. It's in between sig figs, so that's Rule 2, so that's how I got 4 sig figs, but also it's to the right of the decimal and to the right of the 7 and the 6. So therefore, it also applies according to Rule 3. So it has 4 sig figs. These 2 zeros right here, yes, they are indeed to the right of the decimal, but they are not. They are not to the right of any significant figures, so they don't count. And they're not in between sig figs, so they don't count. This 0 here is to the left of the decimal. So again, it doesn't count. All right. So those are the 3. And again, if I just want to talk about uncertain digit for this one, it would be the 5, the first sig fig going to the left. This one would be the 3, the first sig fig going to the left. And this one's a little tricky. The uncertain digit is the 3, because again, it's the first sig fig going to the left. So that 0 doesn't count. So this 3 is the number. So there you go. That is how you identify significant figures, what are significant figures, and what an uncertain digit is.